Hello class. This will be your first lesson on Introduction to Programming using Python CS10. And by now I hope that you have already installed your Python program. If not, let me show you real quick how to get it and then install it. So go to your Firefox or whatever browser you got. Type in Python. And you will see the downloads here. Click on downloads. Right here, this yellow thing here. This is for Windows, people with PC, Windows 10, and download this version, install it, follow all the defaults. And for Mac, click on this, download the latest Python 3 release, 3.8.3, and then install it. After you have installed it, for the Windows people, you can go over here and type IDLE, and you will find idle here. For Mac, you go Finder, Applications, and you will locate IDLE, Python. So I'm going to click this to start Python IDLE. So as I've said before, the Python shell is the first window that will open up. And this is the window that you can do one line of code. So for example, I want to just print hello, hello class. There you go, it prints hello class. And you can also use it as a simple calculator. 5 plus 3, that equals to 8. And the next thing you can do with the shell is it is the output window if you write codes. Now I'm going to show you how to open the window to write actual codes. Go to File, New File, and there you go. You have this untitled scripting window. So this is called a scripting window, and this is where you write your codes. All right, now let's get back to the class, and let's look at Python input and output. Now, typically, there are 3 steps in writing a complete program. The first one is input or data. You must have input or data before you can do the next step, which is to process or do your calculation. And then finally, you have your output. It is important that when you write a complete program, you have these 3 steps in the order. You do not want to rearrange the order. For example, you can't calculate. You have no data to calculate. So therefore, you have to have your data first, then you have your calculation. And finally, if you want to output whatever you have from your data or process or your calculation, you have your output at the end. Now, as you get into more into the intermediate and advanced programming, you see that even you might not see it very clearly now, but you will see that even these 3 steps in this order will have to be followed. All right, so remember input, processing, output. So when you write your codes, from now on, think of these 3 steps. It's just like your English class, when you writing class, when you have to write your essay, and it is what? Introduction, body, and conclusion. Same idea here. All right, let's look at one of the component here, the output. How do we print information onto your screen? So let's look at the first one here, print function. Anything with a parentheses at the back of a word is called a function. So for example, we can say print hello world. Now, to print hello world, we saw that in our previous shell where you type in print hello class. Well, basically that's what it is, okay? Print hello world. Now notice that we have a single quote and we have double quote to enclose what you want to print. So both single or double quotes can be used. Now let's look at some definitions here, strings and string literals. Each piece of letter is called a character. So A, B, C, D, E, F, G, those are character. So there's each piece of a character or a letter. Now a sequence of characters is called a string. So when you put all these characters together, it becomes a string. Then there is this term called string literal. The definition is when the string appears in the actual code of a program. So you call it a string if it's a sequence of characters. And the proper way to call a string that is part of a code, which is enclosed in quotes, is called a string literal. Now, most people would just call it string. If your string literal have single quotes, then use double quotes. Let's take a look at this. Suppose I have don't fear. Let me pull out the screen. We're gonna use the shell here, and we're gonna type in don't fear. So if I print don't fear, oh, where did I go? Here. Print. Okay, and I'll use the single quote. Don't. Now there's a single quote right here. See what happened if I use a single quote to enclose it? Don't fear. Notice that it's not green anymore. It turns into, the default color, which is black. Now here, hello class, it is enclosed in double quotes. So in this sense, I am not allowed to open a single quote and then close the single quote and then continue with that. So what happens is it has to be consistent. If you start with a double quote, you end with a double quote. So here in this case, it started with a single quote and it looks for the end of the set of the single quote, which is here. So dawn is the string, but anything else after dawn, what is that? Because it's not enclosed with a set of quotes. So therefore, what we can do is we can, you see that? It says syntax error. So what we can do is to put them in double quotes, because we can't use single quotes because single quotes is already in my string. And now it works. Now let's take a look at another example. What happens if my string has double quotes? For example, let's see here. What if I have read Hamlet from Shakespeare? So let's say I have this, read Hamlet, oops. So read Hamlet from Shakespeare. What if I want to print this string? Well, if I use single quotes, I'm sure it will work. But if I use a double quote, it won't work. So let's try this. Take a look. It gives you a syntax error. Because why? Inside my string, Hamlet was double quoted. Well, guess what? When I open my string with a double quote, what Python will do, it will look for the next double quotes, which is this guy here. And that will be the end of my string. And this Hamlet here, if you take a look, it is not green. And that is not a string, and it can't be there. So there's something wrong there. But over here, this is a string. So this part here causes the error. So to fix that is, since there's a double quote inside, what we do is we're going to go ahead and use a single quote for this process. Oops. All right, let's do this. All right, so what we do is we're going to go ahead and change this to a single quote. Notice Hamlet is no more. We have changed to green. And now if I hit enter, it will print read Hamlet from Shakespeare. So that sounds really good. So if you have double quotes in your string, you will use single quotes to enclose your whole string literal. If you have single quotes, then you use double quotes. What happens if I have this string that you want to print? How about this? What if I have this string and I want to print this? Notice that in this string, I have a single quote and I have double quotes. Well, if I use a single quote, it won't work. Because why? There's a single quote in my string. And if I use a double quote, that won't work either because there is a double quote in my string. So what I need to do is Python has oops, I can't do this, huh? Python has this triple quotes. So it's 1, 2, 3. And then I'll end this with 1, 2, 3 single quotes. And voila, it printed. Now I can also do this. I can use triple double quotes. So this is double, double, double. And here is double, double, double. All right. And now it will also print. So Python allows you to use single quotes, double quotes, or triple quotes. And here on the left panel, it gives you some example on how to use a triple quote here. I'm reading Hamlet using a set of double triple quotes. And then here, the second use for triple quotes, you can use this to surround multiple lines. So if I want to print 1, 2, 3 on 3 separate lines, I will use a triple quote, and this will give me some sort of a formatting. There you go. So if I do this with triple quotes, then 1, 2, 3 will be on 3 separate lines. All right, in this section, we're going to look at comments. And comments are notes for humans, and the Python interpreter ignores it, which means it is only for documentation purposes. It is not part of your codes. And so when you put in comments, it is for humans to read, not for the Python to run it as a code. So how do you write comments? Well, you put the pound symbol in front of your sentence or comment, and that will make this non-coding or non-coded. Now, Python does not have multi-line comments. So unlike people who are in the C and C++ classes that you learn how to write multi-line comments, in Python, there's no such thing as multi-line comments. Next, we talk about escape sequences with strings. This allows you to put special characters in strings. So for example, if I say print, this should be a small letter, print fancy candy, but I put 3 tabs in front before I print fancy candy. Well, let's try this out and see if we can do this. Let's open up idle. And this is the shell. And I'm going to go ahead and open the new file. And this is new file, and this is where we type our codes. All right, I've rearranged the windows here. I have left your notes, and on the right side, this is going to be the scripting window where we type our codes. And over here is going to be your shell. Now, because there's only one line of code over here, I can always go to the shell and try this. It says /t/t/t, fancy candy, close it, and take a look. Well, tab, 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 3 tabs. Depending on how you set up your tabs, normally for Python, it should be 4 characters or 4 spaces for each tab. So it all depends on how you set it up. So if you want a new line, you put /n. Let's see, I'm going to put /n first. And then let's say fancy candy. And notice that a blank line has been printed because it says go to the next line. Now notice that print itself will actually give you a blank line at the back here. You do not need to put a blank line here because Python automatically inserts a blank line in there. Okay, so let me show you what I mean. You do not need to do this because Python automatically inserts a blank line for you. All right, if you use the print statement. So if you want to use a bell, so ding, then guess what? You use /a. Now it doesn't work too well with most computers. You have to go and configure your sound. Now if you want to print a single quote, for example, here it says Henry the Great is not great. So basically what I'm trying to do here is do this. Print Henry the Great is not great. Right? But I can't do that because if I do this, so let's try over here. I'm going to just copy this over. And let's say print Henry the Great is not great. Now when you copy over from your Microsoft Word, you will have to retype all the quotes because those quotes don't work. All right, let's take a look. Because I have double quotes, single quotes. Remember what we did in the last video? When you have a double quote and then a single quote, this should take care of the single quote, right? So it should work. Yes. Now another way to do this is this. What if I have single quote here? That will give you a syntax error. That won't work. So how do I make that to work? All right, so what we need to do is we're going to change this to single quote, right? Single quote. You know that don't work. We put the backslash right before the single quote, and that will allow you to print it. So the escape sequence to print a single quote is a slash quote. So what if I have, let's say I have this, and this turns out to be a double quote. And you know that's not going to work. So what I do is put a backslash here and a backslash here, and that will make my double quote into a printable double quote. So take a look. To print the backslash, you could just straight put the backslash into your string. We take a look, it does work here. Or if you just want to be super safe, you can use the double backslash, and then it will print the backslash by itself. It's not double backslash, but it will print a single backslash. Now let's look at concatenating strings. Concatenating means to join strings together. So let's say I have a string here. It says, long live the king and don't forget the queen. Now, how do I put this into one sentence? So what we do is we use the plus symbol, which is for concatenating, putting two strings together. So let's go ahead and copy this. Remember to change the quotes. So long live the king. And we have the plus symbol here. This is used for concatenating two strings together or two sentences together. There you go. Now take a look. Long live the king. Don't forget the queen. Now, I need to put a space in between here, and therefore I left a space here. So now if I do not leave a space, so let's say I'm going to print this again. And I use the concatenate without a space. Notice what happens. there is no space. Right here. Right here, there's no space. So you make sure that if you want a space, make sure you put a space before the D or after the exclamation mark. But if you just leave it as it is, the string without space, then guess what? When you concatenate, no space will be given. Next thing we're going to talk about is repeating strings. How do you repeat strings? So for example, I have pi 6 times. How am I going to print pi 6 times? Well, you could do it this way. You could say print pi, 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 pi. Well, 1, 2, 3, 1, 2, 3, 4. It looks like 6 to me. Okay, so, and I could do that. But I can also use the multiplication symbol. Make sure you quote your string. And then use the star symbol. The star means multiplication. 6 times. You hit enter and it will print pi 6 times. So what's the purpose of this? So for example, if you want to print a dotted line across the screen, so I can do this. So I say print quotes. Okay. Well, how many times do you want it to be? 20 times? There you go. Now you have a dotted line across the screen. Hello, let's start learning how to write your first program. I'm going to write a program, and the program is to find the sum, average of 3 integers. Now, the first thing we need to do is we need to figure out how to solve the problem first. You cannot write a program if you cannot solve the problem. So this class is basically a problem-solving class, and also a language class where you learn how to write a computer program. So first, solve the problem. So first, how do we calculate the sum of 3 numbers? Well, let's say I have 3 numbers. I have 10, 20, and 30. So what I first need is data. Then the next step I have to do is calculation. So I need to add them together. And that gives me 60. And the next step I want to do is to calculate the average. So I take 60 divided by 3, and that gives me 20. So this portion here is going to be your calculations. And the last part is we would like to do the output, where we will print information. So given this, let's figure out how we can write programs. Now, writing computer programs, we need to use algebra. So let's review our algebra. We have 3 values here, 10, 20, and 30, but I can't just call them 10, 20, and 30. So we need to represent this as some form of algebraic equation. So I can call this num1 is equals to 10, right? And I can say, hey, num2 can be equals to 20, and num3 is equals to 30. Now, the next step here is to calculate the sum. I can say the sum or the total is going to be what? 10 plus 20 plus 30. Now, this is no good for computer science or programming. You would like to represent all this 10, 20, and 30 into algebraic or variables. So total is equals to num1 plus num2 plus num3. Because these variables were there earlier on and we have assigned them values. And now I can use the variable names and calculate and then assign them back into this new variable called total. And I want to calculate the average. Let's call this average. And I'm going to use the variable that we have before called total and then divided that by 3. Now we have all these variables, and now we can go ahead and write our program. Now the variables are important because variables in programming assigns or allocate memory to put your values. So if you assign variables, means that it will allocate memory and then it will assign the value to that memory. So statement means is this: I'm going to assign the values on the right to the variables on the left. So let's look at a simple one. So num1 is equals to 10. This is a very simple assignment statement. What it says here is I'm going to assign the value of 10 to the variable called num1. The variable must be always on the left-hand side, and the variable has to be on the left-hand side, and the value must always be on the right-hand side. I can't do this. Okay, this is wrong. Right, now we have solved the problem of the sum and average. Now we need to start writing the code. We have all this information here. We have the data, and the data now is num1 equals to 10, num2 equals to 20, num3 equals to 30. We have the two formulas and equation that we needed to do the calculations, and all we do is write the print statement. So let's go ahead and start Python. Let's do here. This is going to be your shell, and I'm going to just put it at the bottom here so we can see the output. Now we're going to open up a new file. This is called the scripting window, and this is where we write our codes. Okay. All right, so let's start writing our codes here. So the first thing we need to do is we need to give our codes a title. And what we do is we write some comments. So student name, student ID, and this program finds a sum average of 3 integers. So in your homework and your lab, you will have to give this at the top of every single question or project or assignment. So the next thing we do is we want to do what? Remember the 3 steps of programming? Well, the first one is going to be data, right? So I'm going to comment this out because I'm going to put a section of codes to define this data and input. And then we have another section called the processing or calculations. And the last one is going to be your output. So now we're going to write codes for the data input. Let's take a look here. We have num1 equals to 10, num2 to 20, and num3 is equals to 30. So I'm going to go ahead and type that in here. So num1 to 10, num2 to 20, num3 is equal to 30, and we have that information as data. Now we need to do the calculation. Now, if we have done this part already, you take a look. It's already done for you. 2 equations are here, and all we do is type these 2 equations here, and we're going to have your processing and calculation part of your codes. All right. Finally, I want to print the num1, num2, num3, and sum and average. We're going to use the print statements that we learned earlier on in class, in the past videos, and we type it in here. And so now we have a complete program. We have the input or data. This is data, so we know we have 3 values. And then now we have the formulas that we need to do the calculations. Everything must be in algebraic equations. Okay, do not put 10, 20, and 30 here. Use what you have before that you have defined as a variable and use it in your equations as much as possible. And then now we print all this information and we need to run. When you run, it will ask you to save this program. So I'm going to say OK to save. I already have it somewhere else, so I'm going to go ahead and save it here. And take a look at the bottom. This is the shell, and this is the output. It says number 1 is 10, so here's the number 1 is, then the variable name is we put here. And then number 2 is 20, which is this value. Number 3 is 30, which is this num3 value. And total is 60 and 20. Now let's take a look in detail how this program is going to be run and what's happening when you run the program. So when we run the program, and Python will read one line at a time. So the first line it encounters is pound, student name, and pound is a comment, so it's going to ignore it. Not going to do anything about it because it's for humans only. Look at the second line, pound, ignore it, don't care. Third line is the pound, let's ignore it because these are just information, documentation for us to read. And then here again, we start a new section of code, give a blank line, start a new section of code, pound again. Now let's look at what's happened here. Num1 is equals to 10. There is no pound. So in this case, if there's no pound, what happened is Python is going to go and check its memory and say, have you allocated memory for the variable num1? Well, the answer is no. So let's go and allocate memory for num1. And you say what? Assign the value of 10 into num1. Okay, so I'm going to assign the value of 10 into num1. Next, we read the next line of code, which is num2 equals to 20. Check the memory. Is num2 the variable num2 in your memory? No, so go ahead and allocate memory for num2 and put in the value, assign 20 to num2. Look at the next line here, num3, it is not in memory. Go ahead and assign a variable name to the memory and assign the value 30 to your memory. So now all these values are assigned to the memory for num1, num2, and num3. Next line here, it encounters a pound. This is a comment, so we're going to ignore it, but we need that to help us to understand that this is a new section of codes, and this is to our calculations. So the next thing we encounter is this variable called total. Let's take a look in memory. In memory, we have num1, num2, and num3, but total do not exist. So what does it do? Well, it go ahead and allocate memory for your total. And next, on the right-hand side, it says num1 plus num2 plus num3. Look at the variable num1. Is it in memory? Yes, it is. What's the value of num1? 10. Let's take it out and put it here, 10. Let's look at number 2. Because there's an add here, please go to the next one. Don't add it yet. Go to the next one. It's 20. Cool. It's in memory. And the last one is 30. It is in memory. Let's add them all up. We have a value of 60, and we're going to store the value, assign the value 60 to the variable total. There you go. Go to the next line. It encounters a new variable called average, and it's not in memory. So go ahead and assign average to memory. And now total is equals divided by 3. So check memory. Variable total exists. It has a value of 60. All right, take it out and divide it by 3. That gives me a value of 20. Assign the value of 20, which is over here, to the variable average. So now this is stored in memory. And we're going to use whatever we stored in memory for other purposes. For example, the last section of code is to print it out. So when we print, number 1 is. So This is a string. Remember, a string is enclosed in quotes. See the quotes here? So number 1 is, and then, now there's no space here, but Python will automatically give you a blank space. This is for me to denote a blank space on this white screen here. Now, what is num1? Let's take a look. Num1 has a value of 10. So here it's going to print 10. So let's go to the next one. It says print this string num2 is automatically assign a blank space. And what is the value? 20. Okay, and so on and so forth. And then you say sum is, and then total. Take a look here, 60. Finally, the average is 20. Hello, everyone. In the last class, we learned how to write a very simple program, sum and average. And let's review. We have the 3 steps to writing a program. First step is to obtain data or input. And then you can do the calculations or processing of that data. And finally, you can output the information. So remember, these 3 parts of the program must be in the order of input data, followed by calculations and output. Now, looking at this program, if you run this program again, it will give you the results where it says num1 is 10, num2 is 20, num3 is 30, and sum is 60, and your average is 20. So that's correct. Now let's run this again. Well, the answer is always the same. So if you do this program, it would be quite boring if you give this to your nephew or nieces to teach them how to do sum and average. There'll always be 10, 20, and 30, and the sum is 60, and the average is 20. And it will come a time when they'll say, hey, this is really boring. Can we have something more fun? So what we're going to do is we will make this program more interactive. We're going to change this portion of the program so that you can ask the user to provide the answers. So let's go ahead and ask the user to give me a name. So we're going to give a variable name called name equals to input. Input means to ask the user to prompt the user for a value, which is a name. And I'll ask the question, what's your name? Next, I'm going to say num1. Now, this is what was there before. What we need to do is to add these things here called int, because we want to ask the user to input an integer, because our program says finds the sum and average of 3 integers. So, int, input, and we'll prompt the user enter number 1, and that will be equals to, close the quote, comma. Now in this input statements, we do not need to put the value 10 in there because the user is going to input the value. So we're just going to go close this, and that will be your input statement. Now let's complete the other 2. So the user can input num2 and user can input num3. The rest of the codes don't have to change. They can remain the same, except that we need to add one more line over here to ask the program to print out the name. There you go, print welcome to Python and print the name. All right, I'm going to close this window and we'll run this again. It will ask me to save. I already saved this before, so it will run. Now let's take a look. They'll ask me, what's your name? Well, let's say my name is going to be Snake Charmer. Enter number 1, 10, 20. If I don't like 30, let's put 40. And there you go. Welcome to Python programming. Snake Charmer. Number 1 is 10. Number 2 is 20. Number 3 is 40. The sum is 70. And the average is 23.333333332. Now let's take a look here. It says, welcome to Python Snake Charmer. Now we can improve on this by putting a comma here. That will make it a bit better. So let's run this one more time. Snake Charmer. Right, let's change the number 30, 50, and 34. Oops. 50 and 34. If we run this, you see there's a comma here and say, hey, welcome to programming, comma, Snake Charmer. If you want to add more stuff, you could. If you want to put comma here, let's put an exclamation mark and see what happens. There you go. Now we'll later on learn how to fix this portion here so that there would be no space. So now you can see that we can improve our program, our last program from our last lecture, by adding these input statements where you can prompt the user to provide you with the value. Now let's take a look at this again. This here name is a string. If you look before the input, there is no data type provided. Num1, because it is an int data type, so we put the int in front of the input statement, and look at the parentheses. There are 2 in the front, and you have to have 2 matching parentheses at the back. Now let's add 2 more lines of code, because if you take a look at how we run this program, let me run this program one more time so you see what I mean. Now watch what happened when I hit the enter key. The program just completes itself, and you see the 3 chevrons, and that's the end of your program. So what if I want the user to signal the program to end by asking the user to enter a quit? So ask user to stop the program, and if I run this, what's your name? Now watch what happened. They asked me to press the enter key to quit. So I'm going to hit the enter key, and now the program quits. The next thing I want to show you is this. You're going to provide me with homework, and in your homework, you're supposed to provide this thing called the codes or the listing here. This is the codes and the listing, and you are also to give me the output, which is this. This is the output. So what do we do? Well, we're going to copy the output. So every time you run, you're supposed to have 5 test runs for me. So let's run this 5 times. First run, I'm going to check. Okay, let's call this Snake Charmer. And then we have 10, 20, and 10, 20, and 30. And here is a first run. So I'm going to hit enter to quit, and it runs perfectly. So what I'm going to do is I'm going to copy this, hit Control C, or you can do File, Edit, Copy, and then come over here Control V to paste it. And then now you're going to put output. Test run number 1. Once you do that, go ahead and highlight this whole thing here. Go to Format, and then comment out the region. You want to make sure you comment out the region, because if you don't, then these will become real codes, and when you run it again, this program, it will not run. Now let's do a test run number 2. I'm going to run this again. It says, what's your name? So I'm going to type Nike shoes. Let's enter some numbers, 45, 35, and 55. Hit enter, check, looks good. Hit enter to stop the program. Copy this and paste it over on this side of your code. Put test run number 2. Highlight this. Go to Format, comment out the region, and then what you need to do is run this 3 more times. And let's suppose you have run that 3 times. And you have copied your output over here. Okay? So you will have test case 1, test run 2, test run 3, 4, and 5. So I've showed you how to use input statements to prompt the user to input the values for your program. And I've taught you how to use a input statement over here, so that it allows the user to quit the program instead of just automatically quitting it. And I have shown you how to run the program and copy and paste your test runs and paste it over to your actual codes. And you shall save this. And this will be the presentation for your homework and for your lab. Because each homework you are supposed to provide me with the codes or listing, plus 5 test runs of this program that you wrote. Also, make sure that your codes for each particular program set for your homework have your student name, your student ID, and also a brief description of what your whole program is about. Leave a blank line when you start a new section of codes. For example, here we have data or input. Then the next section of code is going to be your processing calculation. Leave a blank line and then put a comment there. And then your final thing is the output or display. And so have a blank line and then start your new section of code. Same thing here, blank line, start a new section of code. And then here's going to be all your test runs. At the bottom, make sure you comment them all out and save the program, and you have a complete program for submission. Hello everybody. In this video, we're going to talk about variable. A variable is a name that represents a value stored in the computer's memory. Well, let's take a look at the assignment statements over here. Age is equals to 25. That is called an assignment statement. And age is the variable and 25 is the value. So when we look at an assignment statement, we have to read from right to left. So this is what it says when we say age is equals to 25. So I'm going to draw you a diagram. We'll say age, and we assign the value of 25 into age. So it says 25, the value of 25 is assigned to the variable age. Let's look at the next one. Width is equals to 30. So what it's trying to say is the value of 30 is assigned to the variable called width. And the last one, if you looked at it, it says just X is equals to I am wonderful. And therefore, what is stored in here is the string I am wonderful. This is a little too short. Make a bigger one. Now we can't do this when we write variables. We can't say 25 is equals to age. Because we read this, it says, can you assign age to the variable 25? Then this is a number. This is not a variable. So this cannot be done. Same thing as width. Can you assign the value of width into a variable called 30? Well, we can't do that. All right, let's look at variable naming rules. How do you name your variables? You are not allowed to use any Python keywords. They are also called reserved words. So here are the list of the Python keywords that you cannot use as variable names. So don't use this for your variable names. Now, your variable name cannot contain spaces, so you can't do this. Let's try one. Account payable. There is a blank space here, so I can't do that. The first character must be a letter A through Z, or capital A through capital Z, or an underscore. So I can say this, account payable. You can start with a underscore. After the first character, you can use characters and numbers. So after the first character, you can use anything like something like this. Okay, this is a 1. And upper and lower case are distinct. So the example given here is num1 is not the same as num1. But the reason being is this is a capital N and this is a small n. So this is not the same. It's a small letter num1. Later on, you'll learn that each single character is represented by a number. And so the number is different for a capital number and a small number, a small letter. Let's take a look at some examples here. We have units per day. Let me remove that red line there. All right, so let's take a look at units per day. Do you think this is a legal variable name? Well, the answer is yes, because it fulfills all these rules. So this is good. The second one is not legal because it starts with a number 3. So there's no good. And here, the last one missed pound 3. Well, here is a pound. That pound is actually a comment. So this will not work either. Hello, in this video, we're going to learn about numeric data types and operators in Python. There are 2 types of numeric data, specifically integers and float numbers. You know what integers are? They are whole numbers with no decimal points, and float numbers are numbers with decimal points. Integers are whole numbers, and float types are representing the fractional part, which I've just described with the decimal point. Now, real numbers are represented as floating points, values, or float. We call these numbers float. And how can we tell Python if the number is an integer or a float? Well, let's look at an example here. If you just type in 1, that is an integer. But if you type in a 1.0, then it is considered to be a float value. So you have to pick whether it's going to be an integer or a float, and we'll look at that a little later when we write codes. Now let's take a look at operators. for numeric data types. These are the same math operators that we use in your math. So the first one is addition, just to add. So 34 plus 1, that will give you a result 35, just like normal math. Minus is subtraction. So if I take a float number 34.0 minus 0.1, it will give me 33.9. And this asterisk, or the star, is the multiplication symbol. So 300 times 30, that will give me 9,000. And a forward slash is called a float division. So let's say I divide 1 by 2. This should give me a value of 0.5. If I put 2 forward slashes, it turns it into what you call a integer division. So 1 divide by 2, but this is an integer division, so it gets a value of 0. Now let's take a look at these two. Let's compare these two. A float division has decimal values displayed. An integer division only shows you the integer after the division. So if you have half, it's 0.5, and integer division for half will be 0, 0.5 will be dropped. Next, exponential to the power of. So let's take a look at this example. It's 4 to the power of 0.5. This means square root of 4, which will give you a value of 2.0. And the last one is called a remainder. So the remainder means taking 20 here. All right, with the pen, 20 divided by 3. 6 goes in here. I have 18. And the value returned is 2. So this is what we're doing with this percent symbol, is to find the remainder of 20 divided by 3 in this case, and the result is 2. You will see later on how we use this modulo or remainder to solve some problems. The next thing we'll look at is the order of precedence for your operators. They are exactly the same as your math operators. So if you know your precedence for your mathematics, it follows the same rule. So remember PEMDAS, parentheses comes first, then next is exponential, then multiplication and division, which is on the same level, and then addition and subtraction on the same level. So here are some of the description for PEMDAS here. Parentheses have the highest precedence and can be used to force an expression to evaluate in the order you want. And I'm sure you already know this. So the next one, exponential, has the next highest precedence. So 2 to the power 1 plus 1 is 3 and not 4, because 2 to the power 1 is 2 plus 1 is 3. Then comes multiplication and division on the same level. They have the same precedence, which is higher than addition and subtraction. And finally, you come to the last one, which is addition and subtraction. Now, one thing you need to note is that when everything is on the same level, like for example, here, 10 times 5 divided by 2, we know that the multiplication and the division are on the same precedence. Then Python will evaluate from left to right. So it will be evaluated this way. 10 times 5, that will be equals to 50. And then it will divide it by 2, that will give 25. So it is a left to right if it's on the same level. Here's a table of the operators and the precedence. I highlighted the yellow ones for you because these are the ones that we will be looking at for now. And later on, we will look at these symbols. Equals, equals, not, and, or. But as for now, we just look at the one that's highlighted. We have the parentheses, the exponential, multiplication, divide, integer divide, and modulo are all on the same precedence. And then plus and minus at the lower precedence than these guys here. Now let's look at an example over here. We have the following expression. Now an expression is a mathematical formula. For example, like this, year mod 4 is equals The equals is checking if this value that's evaluated is it equals to 0, and then year percent 100 not equals to 0, or year percent 400 is it equal to 0. Now we don't have to understand all these things yet, but let's say I like to evaluate this and it looks a little bit more complicated and I'm not sure which goes first. Well, what you need to do is put parentheses. What I want to do is put the parentheses over here, which means I like to evaluate this whole expression first, and then go and do this expression and this expression, and then we do the and or the or depending on the precedence that you see on the table above. Here are some examples for you to work on your own. So 5 plus 2 times 4. What's the value? I give the answer here. So why don't you try that out when you review your notes. All right, let's look at adding strings and numbers. Now, if I have this, that's a string. And I try to add a number, that is not allowed. Why? Well, because the first thing here they see is a string. And so the expectation is when you see the plus symbol here, it thinks that it's going to be a concatenation, which means I want to add a string to a string, but here happens to be a number. I can't add a number to a string. Similarly, if you start with a 5 and that's a number, and you follow by a plus sign, well, what it's trying to do is it looks at the plus sign, it looks at the 5, the plus sign now is become a addition. It is not a concatenation of string, but an addition. I can't add a number to a string, and so this is also not allowed. But if I do this, then that's okay. Why? Well, because now 5 is no more a number, but it's a string. So a string concatenate or join a string, and that's acceptable. Now let's look at Python math expressions. Programmers use the operators shown in the table above to create math expressions. The table I'm referring to are the mathematical operators, which is this table here. A math expression performs a calculation and gives a value. So the following is an example of a math expression, 12 plus 2. So this expression will result in a calculated value. Now variables may also be used in math expression. For example, suppose we have two variables and we call them hours and pay rate. And if you'd like to multiply them together, we'll take the variable hours, multiply by the variable pay rate. And this will result in a value for hours times pay rate. Now suppose we want to store the calculated value from our math expression in our computer. We will create a variable called, let's say here in this example, pay. And then on the right hand side of the equation, we have the expression salary plus the bonus. And on the right hand side, all the variables must have a value. You cannot not have a value on the right hand side. So salary must exist and bonus value must exist. After the calculations, we store it into the pay variable. Here is an example to show you how it works. Let's run the program and see how Python do its work here. Line number 1, it sees the pound symbol. That's a comment. So this line is going to be ignored. Then it goes to the next line number 2, and it encounters a variable called salary. And it checks in its memory and see this salary has been allocated memory. Well, right now it is not there. So let's go ahead and allocate memory for the variable salary and assign a float of 2,500 in there. It goes to line 3, a blank line. Line 4, comment, ignored. Line 5, it checks. It sees a variable called bonus. Check into its memory, and it says, hey, memory has not been allocated yet. So let's go ahead and allocate some memory for bonus. And let's assign 1200.0 as a float into the variable. Line 7 and 8 are both comments, so it's going to be ignored. And then now it goes into this assignment statement where the left-hand side is the variable that will store the resulted calculation of this expression, salary plus bonus. So when it encounters this, it checks its memory. Say, hey, pay is not in memory, so let's allocate memory for pay. And then it's an equal sign. It goes and look for salary. Salary does exist, and it has a value of $2,500. All right, let's pull out the value. And then it has a plus symbol, which means let's go to the next thing that's on it. And it's a bonus. Let's go to the memory and check. Is there a value for bonus? Well, yes. Now add these two up. It should give you 3,700. And now we assign this value into this variable. So now pay will have a value of 3,700. Comment, ignored. Finally, print your pay is. Go to the variable pay, pull out 3,700 and pay and print 3,700 here. Now let's take a look at how you will convert your mathematical expression or your algebraic expression to programming expression. This applies not only to Python, but applies to all other programming languages that you will learn later. So if you look at this math expression 6b, it means 6 times b. To write that in Python, it'll be 6. This is the multiplication symbol and the variable b. 3 parentheses 12 parentheses in math means 3 times 12. So 3 multiplication symbol and the value 12. 4xy means 4 times x times y. Here's the expression. 4 multiplication symbol, x multiplication symbol, and then y. Now let's take a look at how we convert some of these algebraic expressions to programming expression. The first one here says x is equals to a plus bc. Now in math, bc, let's assume that bc is not a variable by itself, but two separate variables, b and c, and it means multiplication. So we have to write this as a plus b times c. Now let's look at this particular assignment statement here. On the right-hand side, it says a plus b parentheses divided by c. Now we all know this is not the same as x is equals to a plus b over c. So if you mean to say a plus b first and then divided by c, use this. What you want to do is take b divided by c first, this value, and then add to a, then use this expression or this expression. So be careful of how you set up your expressions because it will result in what you call a logic error. And logical errors are mathematical errors, and they are very difficult to debug in your program. And here are some algebraic expressions. And when you go through your notes, I would like you to review them and try and work out the Python statements. These are called statements because you have a y here, and these are called assignment statements. So try and work this out and see if your answers are correct. Now let's look at converting between integer and float. Right here we have a variable called f value. And a float of 2.6 is assigned to this variable. And I would like to convert this 2.6 into a integer. So I created a variable called I value. And on the right hand side of my assignment statement, I take the variable of f value and convert it into an integer right here. So what will happen is the value of I value now will turn into an integer and has a value of 2. Now assume that right now we have a variable called I value and it has an integer of a value of 2, and I'd like to convert this into a float value. So I went ahead and create a variable called f value. And on the right hand side over here, I put in the I value and I'm going to convert it into a float. And this will convert it into a float value of 2.0. The next thing we'll look at is how are we going to format your numbers so that they look nicer and better, and also to specify the number of decimal points. To do that, we use this function called format. And let's say we have a number here and we'd like to format this into a 2 decimal places. We have to use this format specifier here. The .2.2f means that it is a 2 decimal places and it's a float number. 0.2 specifies the precision, how many decimal places, and f specifies the data type. Now let's look at an example. We use the print function, and inside here we use the format to format this number to 2 decimal places. I'm just going to go ahead and can't do this. Select, and I'm going to open up my Python here. And this is my Python shell. I'm just going to go ahead and copy this and put it over here, and I'm going to hit enter and take a look. My 12345.6789 with 0.2f decimal 2 decimal places and the float data type specifier, it will turn it into a 1.21345.68 2 decimal places. Notice that the 0.67 here is changed to 0.68. If I want to do 1 decimal place, I would use 0.1f. Okay, so here's 0.1f. All right, this is too much. Shouldn't be that way, it should be this way. And there you see it's 1 decimal place. And if I like to put a string in here called the number is, and then you print the value of the number. Let's make it a little bit bigger. Well, we have an issue here because of the quotation marks. So you have to be careful with copying from Microsoft Word into your Python IDE. You need to change the quotation marks. So you enclose the string here, just like you do a normal string when you print it. Put the comma, followed by format, one space. And then here's your number, or you can put a variable in here too. And then here's your specifier. If you hit enter here, this will give you the number is 1.23. Now what if we want to insert commas into your numbers? We use the comma separators. So let's go ahead and type this in. So we have print format, the number, and then we put the comma in front of the decimal point. So let's take a look here. If you want to put a comma, put a comma here, and then the decimal point. Now let's run the line of code, and there you see the comma showing up right here. So you can try the rest yourself. If you do not set any precision, like this example over here, let's run this. Notice there is no 0.2f or 0.1f, just a comma. Let's see what Python will do if you leave out the precision. So notice here is 0.2f. There's no precision here, 0.2 or 0.1, nothing at all. So we hit enter. Python will automatically make this into 6 decimal places. Notice 1, 2, 3, 4, 5, 6. Now let's look at the next one when we have width specifier here. What is width specifier? Well, it defines how many columns you want to fit this number in. So in this case, the width specifier here is 10, comma, dot 3f. So it's 3 decimal places, but all this number will fit into a 10 column format or grid. So it will look something like this. I will draw the thing for you. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number will have 3 decimal places. So it'll be 6, 7, 9. So it'll be 9. Always write from the back if you are planning this yourself. The decimal place. A column will also be given to the decimal place. And then it will be 5, 4, 3. And then there is a comma, 2, and 1. So it fits nicely into this 10 columns. Now what if I change this into a (13 columns formatting? So instead of 10, I have 13, comma, dot 3f. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 columns. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so we're going to go backwards. So we have 9, 7, 6, dot, 5, 4, 3, comma, 2, 1, blank space, blank space, blank space. So this will give 3 blank space in front, and the reason why we use with specifier so that you can align your output. So let's run this one here first and see how it looks like over here. Make it a little bit bigger. All right, so this is going to be 10, dot 3F. Oh, again, that's the quotation marks. We need to fix. Let's change the quotation marks here. Now if you run this, it should run. So if you look at this, it fit nicely into your 10 columns here, and the comma, this comma here, Python will automatically put in a blank space for you. So you do not need to worry about this blank space, because when you do the format, the number is this comma here. This comma here will automatically insert a blank space for you. Now I'm going to redo this. And I'm going to change this into a 13 column width, and take a look what happened here. Notice the blank space here? Well, there are 3 blank spaces you can't see, but if you align this here, 3 and a 1, a comma here, there'll be 1 blank space. The 2 here, 1 blank space, and a 1 over here, 1 blank space. So when you want to plan out your output, draw the diagram like this, and then you will fill it in from the back to the front, and whatever is left, the column that you set, let's say here on 13, you have 3 extra blank spaces as shown over here. Now let's take a look at how we format integers, because previously we were formatting floats, and floats has decimal places, but integers do not have decimal places. Now, the format specifier here is going to be a D instead of an F. F stands for float. D stands for deca. That means base 10. So as an integer, in this case, it says column width of 10. Put a comma in there, D. So let's try and print this. All right. So insert a comma, but there are 10 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next thing we're going to look at is how are you going to format floating point as percentages. So let's say I want 50.0000%. I will print 0.5, that is 50%, and you put the percent symbol at the back, and that will give you this output. So let's try it. Now, if you want not to have any decimal places at the back and just integer of 50%, just put .0 or 0.0. That means there is no precision. So in this case, 0 precision, it will give you an integer. So with 0 precision, let's run the codes. There you go, 50% without any decimal places. Now, if you want 2 decimal places, you put 0.2, just like your floats precision that we did earlier on. There you go. Now let's write a program called currency. And we're going to set the pay is equals to 5,000, which is a float. We're going to calculate the yearly pay as the pay, which is this value here, multiplied by 12. And then we're going to print your annual pay is with the dollar sign included. Now notice this symbol here. That's called a line continuation character, which means if your line is too long, you don't want to type it all on one straight line. So for example, if I do this, and let's say this is way long out here, and I don't want that to go all the way out, I can shorten it by putting this line continuation character. It allows you to go to the next line. And then if I have another place I like to put this, I can go ahead and put one more here, and that will allow me to go to the next line. I don't think this is necessary. This is way too long, so I'm just going to put the separator in here. So let's look at a couple of things that we are looking at over here. So if I look at my program, I've set a variable pay and assign a value of 5,000 to it. And then it looks into the next line and say yearly pay is equals to pay times 12. Now yearly pay is not assigned yet into my memory or allocated. So I go ahead and allocate that. And then it says pay times 12. Now this is the right hand side. The variable pay on the right hand side, must have a value. Let's take a look. Pay, it has a value of 5,000. That's awesome. So 5,000 times 12 should give you 60,000. And then the next line here is to print your annual pay is, go to the next line, continuation, format yearly pay, which is this variable with the value in there, to 2 decimal places. And here's this thing called the separator. And what it does is, do not give a space between the dollar sign and the $60,000. Because here it says no, 2 single quotes, and there's no blank line. Now, if I leave out the SEP, Python will automatically insert a blank space. Here, remember this comma I mentioned earlier on? This comma will automatically insert a blank space in Python. So let's try out this code and see how the program works. Let's start Python, idle. And this would give you the shell where the output will go. We're writing a code, so we cannot use the shell. We have to open a new file. So this is going to be your scripting window. And now I'm going to type my codes in here. And we're going to try and run this program. Notice that it will ask you to save. Let me go save it here. Let's call this pay. And there you go. You have your result here. Your annual pay is 60,000. Now this code looks pretty bad because, it's this line here should, if you want to put a new line, go ahead and put in the space so it's easier to read. Let's run this again one more time and hope it runs. All right, so it runs properly. So now notice this SEP here, there's 2 single quote with no blank space. So here's quote and quote. I did not hit the space bar. So this will give you a no blank space because the separator says no blank space between the string and this argument here. This is called the argument. So there's no blank space here. Now what if I remove the separator? Let's run this program again. And this time, Notice there's a blank space here because this comma here allows Python to automatically insert a blank space. So if I want to suppress the blank space inside here, I would have to use the separator. Now if I run the program again, notice the blank space is gone. I can put other stuff in here if I like to. If I put a star, 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 and look what happened to the separator. It put 3 stars in there. All right, let's look at more data output. If I type these 3 lines of code and print it, it will display 1, 2, and 3 on 3 separate lines. Now, what if I want to display them this way? But I still have to use the 3 print lines. So what I do is I'm going to use this AND over here and say, hey, at the end of the line, okay, put a blank space and don't go to the next line. Basically, it suppresses, it goes to go automatically to the next line. So if I do print 1, what Python does is when it's done printing, it will go into the next line and print 2, next line and print 3. If I like to suppress that, see here, 1, 2, and 3 on 3 separate lines. But if I want to suppress that and not go into the next line, I will have to use the END and then decide what I like to put in here. Let's say a space. It will put a space in between and will suppresses it to go into the next line. So let's try and see this code here and run it over here and see how it works. All right, at my Python scripting window, I've typed in these 3 lines of code. I'm going to run this. And it does shows 1, 2, 3 on 3 separate lines. As I've said, I really wanted to print this on 1 line, but using 3 statements of print. I'm going to put in the END. This will suppress, going to the next line, and I'm going to use single quote, a blank space, and a single quote. And I'm going to do it for the next one here. And I'm going to run this. Notice now it's all on 1 line because the END suppresses the print statement from going to the next line. Now I can also add like a star in here and put a star in here, and this will put a star in between the 3 words. Lastly, we will look at the item separator. We have done this already earlier on with the pay program that we looked at. So let's do a quick review. If I want to print 1, 2, and 3 this way, it will insert a blank line because of this comma here. Notice the comma here will insert a blank line here. The comma here, a blank space, and a blank space here. Now what if I want to suppress the blank spaces? I will use the separator, and there's no blank space between these 2 single quotes. So let's try this out. We'll put 1, 2, 3. Let's go back to our Python here. Let's put it at the bottom here for the separator. So now if I print this, let's remove this guys here. It will print 1, 2, 3 with a blank space. If I like to suppress these 2 blank spaces in between, I will go ahead and put in a separator and a single quote with no blank spaces. Now if I run this, there you go. The first one have blank space because this comma here automatically inserts a blank space. But to suppress the blank space, I use a separator. I can also add characters if I want to. Like before, maybe I'll put $sign. Now if you run, we'll have $3 inserted in the separator. Hello everybody. In this video, we're going to show you how to write programs. So here are two programs here that we will learn to write. So we're going to start with the first one. Write a program that converts Celsius temperatures to Fahrenheit temperatures. The formula is as follows. And so here's the formula. F is equal to 95C plus 32. And the program should ask the user to enter a temperature in Celsius and then display the temperature converted to Fahrenheit. Now the first thing we need to do before we start writing the program is to plan it out. So let's start doing that right now. Let's put in those three things, or the three steps that we have learned so far in writing a program. So we know the first step in writing a program is going to be input. And then we're going to have calculations or processing. And finally, we are going to have the output or display. So by looking at the question here, it says the program should ask the user to enter a temperature in Celsius. So that will be your input statement. Input Celsius. What is the processing or calculations? It is given here. Fahrenheit is equals to 95C times 32. So we need to develop the equation for this. So we have given this as F is equals to 95C plus 32. We need to convert this into a Python expression for this. So F is equals to 95 times C plus 32. Now that we have that algebraic equation turned into Python expression, we can put it under the processing and calculations. Let me erase this and let's put it in here. Fahrenheit is equals to 9 divided by 5. Here, I made a mistake. Let's change that. 9 divided by 5 times Celsius plus 32. Finally, we're going to output the result, and we're going to print that is equal to, oh well, we're going to put in the Fahrenheit. And then, and how many degrees Fahrenheit. Notice that this is the string for this. This is the string for this statement. And right here is your variable Fahrenheit. This is the string. And right here is your Fahrenheit. It refers to this variable Fahrenheit that we have in the processing. So let's take a look at the program that we have planned out before we transfer it over to Python. Remember, the first step when you write a program is to first plan it out, work out the logic, work out the calculation processing, and do all these 3 steps first before you start writing your program. So let's write the program now on the Python idle. So now we have the script window open up. I've already started the shell, and from the shell to the scripting window. If you forgot how to do that, I'll show you real quick. Go idle. This is your shell. We don't need the shell right now, so we start the scripting window, new file, and that's your scripting window. I'm going to go and close this shell first, and we shall write the codes here. So it says here, the first thing we need to do is do the input statement. So I'm going to start putting your student name. Next is your date. Next, a brief description of what this program is all about. Program to convert Celsius to Fahrenheit. Now, if you are doing your lab or your homework, make sure you add your lab 1 question 1. And if you are doing your homework, you will say homework 1, program set 1, to that effect. So for this example, it is neither a lab or a homework. You do not need to submit this to me at all. We'll just leave this as example. Next, we're going to write the input.
Let's look at another example, rate. Now, state text rate
The
is
user will input
so basically,
Celsius.
if you have done,
so we'll type this in, Celsius equals. We like the Celsius to be of float data type, so we have the float data type there. And then the input statement here, and this is the prompt to prompt the user. Now, so that is done. We have completed this part here. The next part is your processing. And all we do is copy this formula into here. Now, what I did was I took the 9 and put a 9.0 and a 5 as a 5.0. We don't have to do that. We can just remove this if you want to and see what the result is. And then we can put it back in and see what the result is. This is to establish that this whole expression is going to be in a float data type. You do not have to specify that in Python, and it will automatically, when you do a integer divide by a 5, it will turn into a float. So the last part here is to do the output. And we're going to print the output this way. Print. That is equal to format. The Fahrenheit. We talked about format in the previous video and lecture notes. Put in the variable name here. Then the precision and also the data type. So we have 2 decimal points. Finally, we're going to have one continuation of the string. So we put a comma and then the string here. Let's run the program. We will call this program temp. Let's put temperature. Now let's take a look. The first line of code here asks you, Celsius is equals to float input a Celsius temperature. So now I'm going to type in a Celsius temperature. Let's put in 0 degrees and hit enter. And that should equals to 32.00 degrees in Fahrenheit. Now we know that we are testing the 2 limits of freezing point and also at 100. Let's run this program again. This time we're going to put in 100. And that should equate to 212 degrees Fahrenheit, which is correct for the boiling point of water. What I just showed you is to run the program, and then we test the programs and to see whether it comes up with the correct answer. In this case, we know 0 is equals to 32 degrees Fahrenheit, and 100 Celsius will always equals to 212, and that shows that my program do run. Let's run it one more time. This time we'll just type in any number we like. Let's put it 55 degrees Fahrenheit, and it's 131 degrees, 55 Celsius, and that is 131 Fahrenheit. That's pretty hot. So let's try one more time. Let's run it one more. Let's put in 27 degrees Celsius and see this Fahrenheit to be converted to 80 degrees. Now here there are 1, 2, 3, 4 test runs. In your labs and homework, for each program, you are supposed to have 5 test runs. The first 2 test runs, we know the answer because we know that 0 Celsius always gives you 32 degrees Fahrenheit, and we know 100 degrees Celsius always gives you 212, so that verifies that my equation is correct. So we run some other Celsius temperature to check, and we run one more time, and let's put it at 25 degrees, and that's 77 degrees Fahrenheit. Now, we have 5 test runs, and for your homework and lab, you will copy these, highlight, Control C, bring it over to your program in your scripting window, Control V to paste it here. And these are going to be your test runs. So next step, highlight, go Format, and then comment out the region. You must comment out the region. If you do not comment out the region, then your output here or your display here will be part of your codes, and you will never be able to run your codes again. Next thing you need to do is clean it up. So what I'll do is put in test run number 1. Now I need to put in the comment. Next one here will be test run number 2. Test run number 3. Test run number 4. And test run number 5. Go ahead and save this. And now you have a complete program that you can submit on Canvas. Please note that all your labs and homework, you must provide me with test runs. If you miss any test run at all, you will get a 0 for your program, even if your program works. Now let's take a look what happens if we put a 0.0 here. We will look over this side here. We will run the program one more time. This time let's try 44.0. No difference. It still gives you a decimal point. Let's run it one more time. Let's put 100 here. And it still do it correctly. So it doesn't matter whether we put a 9.0 or 5.0 or leave it as 9 divided by 5. But it's better to put a 9.0, 5.0 to show in your program that this is going to be in the end result into a float result for your expression on the right hand side. This will come into importance when you do C programming, but for Python it will automatically take care.
Let's look at another example of a program that we are going to write. Write a program that will ask the user to enter the amount of a purchase. The program should then compute the state and county sales tax. Assume the sales tax is 5% and the county sales tax is 2.5%. The program should display the amount of the purchase, the state sales tax, the county sales tax, the total sales tax, and the total of the sale, which is the sum of the amount of purchase plus the total sales tax, and it gave you hints over here. So let's take a look at the program. First of all, it says ask the user to enter the amount of the purchase. So this is going to be an input statement. The program should then compute, that is your calculation, the county and sales tax. Then the next part here is given some information here. Assume the sales tax is 5%, sales tax, state sales tax 5%, county tax is 2.5%. The program then asks you to display. So that will be the output of all those information that's stated over here. So let's do our planning first. First thing is input. And what we want to input is going to be ask the user to enter the amount of a purchase. So we will be input purchase. which is the how much it will cost. Next, it says compute. We will look into processing. And calculations. Now, what do we have to calculate and process? First, we need to calculate the state tax. Let's write this down. We need to calculate the county tax. Let's take a look. Calculate the sales tax, county tax, and the total sales tax and total sale. So, what is the total tax here? We're going to have total tax. And we're going to have the total sale. Now let's find out what is the equation or formula to do sales state tax. That will be purchase multiply by your state tax rate. Now state tax rate is a given information here, which is 5%, and the county tax is 2.5%. So these are given information. So I'm going to put a little note and say given state tax rate is equals to 5%, and the county tax rate is equals to 2.5%. So here is supposed to be your purchase times your state tax rate. So we could actually put the state tax rate of 5%, which is 5%, or this is also equals to purchase multiplied by 0.05, just like it says over here. But this is a given information, and we do not wish to use this number. We'd like to convert this into a variable. So it would be preferred to do it this way: purchase time state tax rate. Well, next one here is going to be purchase times 2.5%, which is the same as saying purchase times 0.025% is a value. But we don't want to use the actual number because it is given. We will just say in general, county tax rate. Let's calculate the total tax. Total tax is going to be state tax plus county tax. And finally, the total sale is going to be purchase plus total text. And then the last part here is the output. And what they ask you to output basically is to print these things. Say here, purchase, state sales tax, county sales tax, total sales tax, total of the sale, total number of things to print, 1, 2, 3, 4, 5. So we should have 5 print lines. So I'm going to print purchase, the first one. Right. Number 2, I'm going to print the state tax. And number 3, I'm going to print the county tax. Number 4, I'm asked to print total tax. Number 5, we're going to print the sale total. Now we're going to write the program. Start your Python. File, new file. We don't need the shell now. So let's look at our information over here. First thing it says we need to input the purchase of the amount. So remember to put in your student name, student ID, the date, and this is going to be text program to calculate taxes. How about state and county taxes on purchases? First thing we do is input. This is going to be a user input. So I'm going to go ahead and type in the input statement. This is going to be a float because we are dealing with money, and money always have 2 decimal points, and therefore we're going to put the float in there. Next thing is processing. Or calculation. And we have here state tax, county tax, total tax, and total sale. And we have given these equations here. So we're going to type all these in. So now we have state tax is equal to purchase times, we're going to give this variable name the sales tax rate, which is going to be 0.05% or 0.5% or 0.05, and then county tax is going to be 2.5%, and then we're going to do all of the rest of the calculation. Next step is going to be our output or display, and we are asked to print those 5 information. And there we go. This is the string. This is going to be the variable that we want to print the values for. and we are formatting the purchase variable with a 2 decimal places and a float data type. Similarly for the rest of the output. So now we're done. We can try and run this program and see what happens. So it asked me to enter a purchase amount. Let's put in $100. Let's see what happens here. Oops, here's a error. Let's read the error. It says here sales tax is equals to purchase times sales tax rate. Error, name. Sales tax rate is not defined. What does that mean? Well, what it means is you have no value for sales tax rate. Remember, in the previous lesson, we learned that on the right-hand side, whenever we have variable names, these variable names must have values. State tax rate does not have a value. We do have a value for purchase because we typed it in. The user input 100. But what is the value of state tax rate? Let's take a look here. Given state tax rate is equals to 5%. So if this is given to you, what we're going to do is we're going to type it up here. And we're going to call these constants for the state and county tax rates. Why are they called constants? Usually tax rates do not change that much, and therefore we call them constants. Like pi is a constant. So 3.14143 whatever, that is a constant and it doesn't change. And because it is a constant, we can place it at the top and caps the variable name so that we know that it's going to be a constant. This is a convention and everybody uses that, so you need to caps it. So the state tax rate is going to be 5%, which is 0.05. And then the county tax rate is going to be 2.5% or 0.025. Now let's run this program again. Enter the purchase, let's say $100. And now we have state tax as $5, county tax as 2.5, total 7.5, and your sale total 107.5. Now let's take a look at the program that we just wrote and see what is the problem. Supposedly these two lines don't exist, so I'm going to replace them now by a comment, which means they will not run. Well, let me remove it totally. So this is where we were in the beginning when we first wrote the program, and we encountered an error. Let's see how the error was established. So pound, 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 pound. So those are comments ignored by the Python program. This is the pound. It's also a comment. So the first thing it encounters is purchase. So purchase is equals to float enter. Now what happened is this variable is the first time Python encounters it, and it checks the memory and notice that it does not exist. So it go ahead and create a variable, allocate memory for this variable called purchase. And now it says, hey, input the amount. So the user enter 100. And now my variable purchase has a value of 100. Let's go down to the next line here. It says processing calculation, calculating the state sales tax. First, on the left-hand side, it sees a new variable called state tax. It checks its memory. Sales tax don't exist, so let's create a memory cell for it. Next thing it encounters on the right-hand side of the equation is purchase. Now remember I said the right-hand side must have values. Let's check. Purchase. The variable purchase exists in your memory and has a value of 100. Next is check state tax rate. Well, let's take a look. The state tax rate in the memory, this variable, no, it is not stored in memory anywhere. So therefore, I cannot pull out a value which causes an error. So what I need to do is to have these two variables given a value. So when I run the program again, let me erase this. So when I run the program again, it hits state tax rate. This is a new variable name that don't exist in memory. Let's go ahead and create state tax rate. And it's a value of 0.05. Next, it encounters county tax. It has a value of 0.025. So now this exists in memory. Next line, it says pound. Ignore. Next, purchase. Check memory. Is purchase in my memory yet? No. Go ahead and create or allocate memory for your purchase. Now let's ask the user to input a value. Suppose the user entered the value of 100. Let's go to the next line of code. Comment. We don't do anything about it. Now we go to state tax. Does state tax appears in my memory yet? No. Let's allocate memory for it and call this state tax. Now it has an equal sign, which is an assignment statement. Anything on the right hand side, variables, must have a value. So let's check purchase. Purchase, yes, it is in memory. It is a value of 100. That's great. Let's take a look at the next one. Let's put down here 100. We have a value of 100. And then we're going to multiply by the state tax rate. Previously it's not there, but let's take a look. When I put it here at the top, now this variable has a value of 0.05. It's been allocated memory and the value has been in the memory. So 0.05 does exist. So 0.05 was state tax rate. And this time it works. Previously it wasn't there, so it says it's invalid. I don't know what it is. So now the state tax after your multiplication, I can't remember what it was, $5. Next line, pound, comment. We don't execute the code. County tax. This is a new variable. Check my memory. It doesn't exist. Go ahead and allocate memory for it. Where's the value? Let's look. Equal sign, assignment statement. Check purchase. Purchase exists, which is 100. Awesome. So there's a value. So it's good. Let's check county tax rate. Is it in memory? Yes, it is there, and it's a value of 0.025. And that gives you 2.5. And it's stored in your county tax variable. Next thing, it encounters total tax. Let's check the memory. Is total text here yet? Nope. So let's go and allocate memory for total text. And it says state text plus county text. Now these two variables must exist and they must have values. So let's check in our memory. State text, yes, it is there. It's been allocated and it has a value of 5.0. So we can put 5.0 here. Let's look at county text plus county text. Check the variable. Variable does exist in memory. It does have a value. Awesome, 2.5. And then now I can store this value on the total text on the left-hand side. So same thing for total sale. Right now it is not in memory. Go ahead and allocate memory for your total sale. And then your, total text, total sale will be 107.5. Because our purchase is already in memory here, 100. And the total text, we have it here, 7.5. We add them up, 107.5. And that works out really great. Now let's look at the printing. The printing says purchase amount. This will print the string just as you want it to be. And then look at the variable purchase here. It does exist in memory. This is variable. 100. So 100 goes in here and at 2 decimal places. So it's the same for the rest. So let's recap. Before you write any programs, make sure you plan it all out. Write out all the information that you are given to you. And if these information that are given to you are constants and don't change, then put them at the top as constants. Then start planning. What is the user input? What are the calculations that you need so you can develop the formulas, the algebraic expression for it? Convert them all into Python expressions. And then write out all the output that is required before you write your program. If you notice that if you do it this way, let me go and shrink this a little bit. If you have done this first and then you write the program, take a look. Input is input. We have the constants here, right at the top given. Processing, all we do is transfer all the formulas over. And then the last part, output, all over here. So basically, if you have done this, then writing your code should be an easy process. Important thing is, remember, if it's a given value and they are constants, put it at the top and caps every single variable name. That is the convention for constants. Next thing you need to remember is assignment statements. The left-hand side can have a variable name with no values, but on the right-hand side, every variable name must contain a value stored in memory. If that is not true, then you will get an error. Hello everybody. In this video we're going to look at control statements, and there are two kinds of control statements we will look at. The first one is going to be decision statements, and these are the if statements, and then the next one will be iteration, and they are loops. Well, so far all our programs that we have written start from one point and we keep writing the codes all the way and we finish it. But now we're going to learn how to start the codes. But we have a fork over here, and we make a decision over here whether we want to go here or we go straight through. And then we're going to execute some other kind of statements. And then we'll go back to the original codes and we finish it at the end. So let's take a look at what are if statements. If statements are decision structure. This allows the program to have more than one path of execution. Well, let's take a look. This is one path of execution, and here is one, and this is the second path. So this is the first one, and here's one and two paths. Causes one or more statements to execute only when a Boolean expression is true. Let's take a look at this flow chart here. Alright, suppose our program starts from here and it's come all the way to this diamond box, and this is the decision box. So I ask a question. Is it cold outside? Well, if it is true, let's not go straight through the codes and the program, and we're going to fork out here and we're going to put on a code. And then we go back and continue with your codes to the end. Now what if it's not cold outside? If it is false, then don't fork out here, but go straight through. So this is what we call the decision statements or the if statements. This is called a Boolean expression. If this Boolean is true, then we go to this path. If the Boolean is false, then we continue with where we were heading. So let's take a look at how a decision structure that performs three actions if it's cold outside. As I've said before, if it's cold outside, if it's true, then we fork out into a second path. We can have multiple statements. So we can wear a coat, we can put on a hat, we can put on gloves, and then we go back and continue with the original program. Now if the Boolean, which is if it's not cold outside, and if it's cold outside, if it's false, which means it's not cold, then we do not fork out in here. We just continue with the program. Here's a general statement for the if statements. So if, this shouldn't be a caps, it should be a small letter. If condition. Now notice there is a colon here. Let me make this better. There's a colon here. Make sure you end your if statement with a colon, and then followed by your conditions. So this if part here is this part here. So if it is true, do this, and if it is false, continue the code. So if your condition is it cold outside, if it is cold outside, then wear a coat, put on your hat, and wear gloves. If it is cold outside, if that's true, the Boolean is true, go wear a coat, wear a hat, wear gloves. If the Boolean, if it is cold outside, false, don't go out here go straight through. So only if the condition is true, we execute these statements. If the condition is false, we skip all these statements. Let's take a look here. If the condition is true, we execute these statements. If the condition is false, then we don't do these statements. We go straight through. So let's take a look at an example here. If the sales is greater than 50,000, then we execute these 3 lines of codes. If the sales failed or is false, and if the sales is less than 50,000, then we will not execute these statements. So therefore, if the condition is tested true, then the statements are executed, and they are not true, then they are skipped. So let's write the codes for this and see how it works. We'll start Python. All right, here is your scripting window. And we're going to start writing the codes here. If sales is greater than 50,000, bonus is 500, commission 0.12, and print, you met your sales quota. I'm going to make it this way so we can see the codes. And we'll type it in here. All right, let's type in the codes. So the first one is going to be if sales is greater than 50,000. Now remember the colon here when you finish your if statements. So if this is the condition, we need to test if this condition is true or false. We end with a colon. Next thing is we want to do the next statement. Now according to the codes here, this is indented. You have to indent all the statements that belongs to the if. So how do we indent? Tab. Hit the tab once, and it should give you 4 blank spaces. Each tab is 4 blank spaces. Now if your tab is not 4 blank spaces, then Python will give you an error. So let's write the rest of the codes. Tab. And it seems like it automatically tapped it for you this time. So now we're going to run. Now, so if this is true, if the sales is greater than 50,000, then it will execute these 3 statements. If sales is false, then it will not execute these 3 statements. Let's run the code. Well, let's call this decision 1. All right, so let's take a look here. It looks like we have an issue here. The program did not run. It tells you trace back, this is an error, and it tells you here if sales is greater than 50,000, and it says name error. Sales is not defined. What does that mean? Well, it means that it doesn't have a value. So let's take a look at what is the problem here. Let's run our codes. First thing it says sales is greater than 50,000. So let's take a look. Sales. What is sales? Suppose we have a memory here. This is our memory area, and we check for sales. Well, what is sales? Sales don't exist. So if sales do not exist, then how can I compare a value with 50,000? So I can't do that. So I need to do something else. So I need to add in one line of code to my program and say sales is equals to, let's say, 60,000. So now when I run the program again, it will say sales, well, it's not in my memory, and I'm going to put 60,000 in there. And then now it checks if sales greater than 50,000. Let's take a look. Sales is 60,000. Is it greater than 50,000? Is this Boolean true? Yes, it is true. Therefore, bonus. Well, we don't have bonus in our memory, so we allocate memory for bonus. And bonus is set to 500. And the commission rate, check memory. Commission rate is not in there. So we allocate memory for it and assign 0.12. And then finally, it prints you met your sales quota. So let's look at our program again, and let's fix it. So this time what we're going to do is we're going to set a value. Sales is equals to 60,000. Now I want to separate a section of codes with a blank line so I can see very clearly. This is a input statement. This is just an if statement with an output. So let's run this again. And there you go. You met your sales quota, because if it is greater than 50,000, then my sales quota has been met, which means bonus is equal to 500, commission rate is 0.2, and print you met your sales quota. These three statements are executed because this if statement here, the condition here, is true. So let's see what happens if the condition is false. Let's put these at 40,000. So if sales is 40,000, it means that it is going to be less than 50,000. This condition is false because 40,000 is not going to be greater than 50,000. So let's run this. It's blank because we are not printing anything. So these three statements are not executed. You do not see the print of you met your sales quota over here. Just in case you don't see that, I'm going to close this, run this again. It's blank. Now let's take a look at relational operators. You have already seen these in your math classes. This is the greater than symbol. This is the less than symbol. This is greater or equals than symbol. This is the less than equal symbol. This is the equal comparison symbol, which is different from your assignment statement. I will talk about that later. And this is the not equal to symbol. So let's look at some examples here. Given A is equals to 4, B equals to 6, and C is equals to 4. Take a look. Is this condition true or false? B is greater or equals greater than or equals to A. So B is going to be 6. Is 6 greater than equals to 4? Well, looks like it is going to be true, because 6 is greater than equals to 4. Let's take a look at A. Is it greater than or equals to C? So A is 4. Is it greater than or equals to C? 4. It is true because of the equal sign here. Let's look at this one here. A is going to be 4. Is it less than equals to C, which is going to be a 4? Well, that's going to be true because of the equal sign here, or the equal symbol. Now let's see this one. B6, is it less than equals to 10? That is also true. Is B6 greater and equals to 5? That's a false. And finally, we'll check is B6 less than or equals to A, which is a 4, which is also a false. So we will be using these relational operators to set up our condition for the if statements. We'll look at that later on. Now let's look at this equal equal and the equal sign. We have learned before that, let's say A is equals to 45. This is an assignment statement. What it means is, check your memory, allocate A, variable A, and assign a value of 45. So what it means is, assign the value of 45 to the variable A. Now this is very different from this. What this means is compare the value of A with the value 45. So let's compare A and 45. Now, before we can even compare, we need to know the value of A. So since we do not have a, we need to compare the value of A with the value of 45 and see if they are the same. This is comparison if they meant to be equal or not. So in this case, A doesn't have a value, and therefore this line of code does not work. So we need to set a value here. So let's set A is equals to 10. Now A is equals to 10, so now here 10. Is 10 the same as 45? Well, in this case, it's going to be false because 10 is not equals to 45. So that's a false. So what if we change the question? And now we have A is equals to 45. And now A is 45. Is that the same as 45? Well, that is a true. So the Boolean for this will be true. The next thing we'll look at is compound Boolean expressions using logical operators. We have already know what a Boolean expression means. We also know what a logical operator is. So let's take a look what it means by a compound Boolean expressions using logical operators. Let's take a look at here. This x is greater than y is a Boolean expression, and a is less than b is another or a second Boolean expression. And the n, a, and d here, we're going to use a logical operator, and, or not, to put two Boolean expressions together. So we need to evaluate this first, and then this, and then we use the and. So what it means is x greater than y? X, is it greater than y? And is a less than b too? Let's look at the second compound Boolean. Is x equals to y? Do they compare them? Is x have the same value of y? And then, or is x equals or compared to z, and x have the same value of z? So this is either this or that is true. Then it is true. The truth table that we'll look at later on will explain all these things to you. And then the last one is not. If the expression x is greater than y is true, then not true is going to be false. So let's say if x is greater than y, and if that is true, not true will be false. Now let's say if x greater than y is not true, which is a false, then not false is going to give you a true expression. Now let's look at the truth table for the AND operator. Let's look at this example here. X and y and a less than b. Now if x greater than y is true, if x greater than y is true, and a less than b is false, then this whole expression here is going to be a false. As long as there's a false in your AND operator, then the whole expression is a false. Let's check the next one. Is x greater than y? If that is a false, and is a less than b, if that is a true, because a false and a true, it will give you a value expression of false for the whole compound expression. Let's take a look at the next one. If x greater than y is going to be false, and then a less than b is going to be false, both are false, then the whole expression is going to be false. If both are true, then the whole expression is true. Now let's look at the truth table for the OR operator. If the first expression is going to be true, and then the second expression is going to be false, as long as one is true, your whole expression is true. So if the first expression is a false, then the expression is a true. As long as one is true, the whole expression is true. Now if both the expressions are false, then guess what? Then the whole expression is false. If both expressions are true, then the whole expression is going to be true. So you need to memorize or know your truth table for the AND and OR operator. It's very simple to remember. For the truth table for the AND operator, as long as there's going to be a false, the whole expression is going to be false. As long as both expressions are true, then the whole expression is true. So for the OR operator, as long as one is true, then the whole expression is true. If both are false, then the whole expression is false. If both the expressions are true, then the whole thing is true. So as long as one is true, then your whole expression is true. Both false, false. Both true, true. Now let's look at the NOT operator. If it is not true, if the expression is true, and you have a not in front, then not true will turn it to be false. If your expression is false and you have a not operator in front of your condition, well then not false is going to be true. Let's look at an example here. If the temperature is greater than 100, now if that is true, therefore if it's not true, this whole expression is going to be false. And then it will not print this is below 100, because if this expression is false, the if statement will not execute. Let's take a look at how this works. We're going to go ahead and start our Python again. We're going to rewrite this, and we're going to set the codes for the temperature. All right. So if the temperature is equals to 100, and it says if not temp greater than 100, print this is below 100. What do you think this expression will be, true or false? So temp is 100. Is 100 greater than 100? Well, it is false. So not false will make this whole expression true, which means it will print this is below 100. So let's run this and see. There you go. So if this expression is true, it will print this. All right, now let's try and make change this into 90. Is 10 greater than 100? Well, 90 is definitely not greater than 100. So this is going to be false, not false. Now this whole expression becomes true now. So if I run this, it says it's going to be below 100, which is correct. Let's run this program again. Let's change this to 110 degrees. Let's check. 110, is it greater than 100? That is true. But there's a not operator in front, so not true will turn this whole thing into false. Therefore, if I run this, there will be no printout. Blank. If you don't see that, let's kill that and let's run this again. Blank. Nothing is printed. So now that we have learned what if statements are and what all these operators are, we will use these operators, relational operators, with the greater than, less than, all those symbols, together with your logical operators and or not to form compound Boolean expressions. And you have to learn the truth tables for the and or operator. Once you get the hang of it, it's very simple. And then now we will be able to start constructing programs with if statements. If statements are very important in programming. In fact, you will see if statements everywhere in your programs. So make sure you learn your if statements well. And we will show you programs on if statements in the next lesson. Hello again. Today we will continue with if statements. In the last video we talked about how where we write codes and then there are more than one path of execution, and one of the things we do is to use if statements. We also talked about relational operators, the greater than or equal symbols and the greater, less than. Then we also talk about logical operators, which are the combining of more than one conditions together to form one big condition. And we use the and, the or the not. So let's write some codes using if statements to demonstrate how it works. Here's the program. It says write a program to calculate the average of 3 test scores. And the grading are as follows. So if the average score is 90 or greater, you get an A. If it is 80 to 89, you get a B. From 70 to 79, you get a C. And 69 and below, it will be an F. So let's assume that your scores goes from 0 to 100. And I can actually write a timeline or a line graph for this. The first one is greater or 90. So it's inclusive. And assume that it goes all the way to 100 maximum score. And it'll be in this range. And then from 80 to 89. It will be in this range. And 70 to 79. And finally, the last one is going to be from 69 and below. So we'll do it this way. And that'll be an F. So I can still continue to represent this in math. I can say 90 less than, right, equals to, this is going to be the average. And this mathematical expression will represent this range. And then the next range will be from 80 to 89. And then the next one is going to be 70. And finally, the last one, which is an F, we can represent this as average is less than equals to 69. We can do that, or we can go from 0 okay, so now we will put this together into codes. As we have remembered, we need to start planning first. And what we're doing here is we write the pseudocodes, which are not actual codes, but are basically codes that is in English, and you'll translate that code, that pseudocode, into real codes. Now, it's good to learn how to write pseudocodes first, because if you can figure out the pseudocodes, you can actually transfer those codes into any language, programming language you want to use. So in this case, the input is input 3 test scores. So input 3 test scores. Next thing is going to be a calc or calculation. And what do we do for calculation? Well, we already know we have 3 test scores. We need to find the total of the 3 test scores. So the total of the 3 test scores, let's call this test. And then we'd like to total these 3 test scores together. We already did that, and we want to find the average of 3 test scores. And with the average, we want to find out which grade it is. And to do that, we'll take the average and place them into one of these timelines, or these line graphs, and see which one it falls into. So to do that, we need the if statements. So this is going to be a combination of output and if statements. So here we're going to start with the if statements. And so we're going to go the first one. Now I'm going to write this mathematically. So as if, right, 90 less than. Now you cannot do this in computer programming. You have to put your less than equals this way. So if you do it this way, this is going to be marked as wrong. So you make sure you don't do that. Okay, so this is not acceptable. So 90 to 100. Let me make this better. All right, so now remember, when you finished the statement for if, you have to put the colon. Do not forget the colon. Now what's the next step? Okay, the next step is going to be print. If this is true, so if 90 is less than equals to the average and is less than equals to 100, which means if your average falls in the range between 90 to 100, we're going to give this person an A. So, or print an A. So remember to indent. You will hit the tab and you print A. Next one. So this is going to be the second range. 80 less than equals to average less than equals to 89. So if it falls into this range, you will get a B, or B will be printed. Let's work on the next one, which is the 70. Don't forget the colon. This will print a C. And then the last one, which is 69 or below, you get an F. So we have a choice of doing this or that. So let's go ahead and just pick one first. We'll just pick the first one. So average is less than equals 69, then go ahead and print the F. So let me make this a little smaller. As of now, we have written the pseudocodes with the input statements here. Let's make it even a little smaller. There we go. Now we see the whole thing. We have the input, calculation of total. We got the average. Now the average will go into the if statement so that they can check for the condition if it is true. If it lies between 90 and 100, then print the A. So let's take a look if it's true or not. So if you got the average of 95, let's say average is equals to 95. Check if 90, is it less than 95? So this will be a 95 here for now. So does 95 lies in this range? Yes, it is, because it's greater than 90 is less than the average is, greater than 90 and is less than 100. Therefore, this statement is true. It will print A. Now let's check the next one. Is 80 less than equals to 95 and also less than equals to 89? Well, is the average greater or equals to 80 and the average less than equals to 89? Well, it does not fall in this range, so this is false. Do not execute this. Go to this one here. So 95 does not fall in this range, therefore this is false. Then this is not going to be executed. And we know 95 is definitely greater than 69, and so 95 is not less than 69 for this case, therefore this is also false. Alright, so far we have written the codes in using mathematical representation, where 90 less than average less than equals to 100. And Python allows you to do it this way so that you can basically learn how to write programs. We're going to demonstrate this first, but after we are done with this, you shall not use this anymore. We will use the proper way of writing codes so that you can apply it to all languages. Alright, now let's transfer this pseudocodes into real codes, and then we can run it and see how it worked out. We're going to start Python. Remember, this is just going to be the shell. We need to open a new file, and this is where we write our codes. I'm going to put this at the bottom here so we can see what happens when we run the codes. Alright, so what we need to do is to write the codes and transfer this pseudocodes into real codes. So the first thing we need to do is to put in the 3 input statements. So I'm just going to go ahead and pound, and we're going to put in your student name, student ID, and the description will be What do I say here? Okay, program to allocate grades or assign grades. Okay, with the average score. So the first thing we want to do is to put in the input statements. So I have test 1, and then I like to use the integer for now instead of float. You can use float if you like to, but let's use integer for now. Now take a look at how we can improve the readability of our codes, because it is important that you need to write your codes neatly and in an organized way so that everyone can read it. Now your code is disorganized and it's a mess. It's very difficult to read, and that's not good. So after you have one section of a code, for example, the first part here is to define who you are, and these are comments. Before we start a new section, make sure you have a blank line, and then give a comment on what this whole section of code is going to do. Now your code is supposed to be self-explained. It's like writing an essay. So the first part here, I put input. This is like introduction. Now it is understood that if I write test 1 is equals to input, this is going to be input statement. There is no need to do this. This is to input first test. This is unnecessary because this line of code tells me exactly what it is. So you do not have to go line by line explaining what this line means. Now, when I give you examples in class or the videos, I will put these things in for you to explain to you what it means, because you have never seen it before or the first time you've seen it. And so this is for me to explain to you what that particular line of code means. Now, by all means, if that line of code that you wrote, for example, this one here, needs a little bit more explanation, then go ahead and write something at the back of it and put a comment. Usually, it is a section of codes like this, and then you write on top what this section of codes means and not line by line explanation. Okay? So I'm going to delete that. So here, leave a space, and now your codes are a lot more easier to read. The next section of codes is going to be your calculations, and I'm going to go ahead and let's say print the average so I have an idea what the average means. So I'm going to go ahead and calculate this calculations. I'm sorry. Let's do calculations. And then we're going to have total is equals to test 1. Leave a space plus, leave a space, test 2 plus, leave a space, test 3. Next line of code, we're going to calculate the average. Is equals to total divided by 3. Oops. Space slash space 3. And I like to do a print here just to tell me what my average is going to look like. And I do not need to state any comments for this. Just give me an idea what the average is, so I'll know if the result is going to be correct, or the grade when it's been printed. Okay, now next part here is going to be your if. Now in the real world, you will not need to put if statements and output. You can just put the output, and the if statements can be a part of your whole output portion of your codes. So next step here is, let's go ahead and type in the codes for the if statements. So the first one here is going to be if 90 less than equals to average, less than equal to 100. So go ahead, if 90 less than equals to the average and less than equals to 100. Don't forget the colon. Now, when I use the relational operators here with the greater or less than or equals to, you cannot put a space in between. That will be wrong. You cannot put a space, so you have to make sure there's no space in between. Next, the next line, if Python does not automatically tab for you like what happened here, you will have to put a tab yourself, which is going to be 4 spaces. So let's count backwards. 1, oh, it just jumped back. So anyway, if I tab, it will be 4 spaces. If not, let's go back 1. I can't because it's a tab. So it'll be 1, 2, 3, 4, and that will be a tab. So then print A. Next one is going to be another if statement. This is going to be the 80 onwards. All right. So 80 less than equals to average. We got it from here, the pseudocodes, and then 70, and then we'll finish it off this way. So let's run the program and see if it's going to run. Let's go save this. Let's call this grades. Let's call this grades 1. All right, so it asked me to enter the test score number 1. So let's use 95. Test score number 2, 96. Test score number 3, let's say 98. Hit the enter. The average score is 96.333, and that's an A. It works out right for the A. Now let's do another test run, because you're supposed to do 5 test runs. I'm going to run this program again. This time I'm going to test for what happens if it is 85. So test score number 1, let's do 85, 89, and then let's put one last one here, 81. Hit enter. Let's take a look if it's going to work out correctly. So we got an average score of 85, and that's a B. And here, this statement here is correct. I'm going to put this over on the left-hand side. Whoops. All right, there we go. Now you can see that first test run is correct. Test 2 is right. I want to test if it is between 70 to 79, would it come up to be a C? So let's run. Let's put 75. Let's put 76. And let's put 78. And that's a C. That works out. Let's run one more time. So enter test score 1. Let's test less than 69. Let's do 50, 40, and 0. The average score is 30, and it's less than 69, and that gives an F. That works out perfectly. Now suppose that we all know that the test scores is only between 0 to 100. And let's run the code to test the outlying values. For example, greater than 100. I'm going to run this. 101, oops, 102, and 105. The average score is 102.666, and there is no score given. So supposedly I'm the user, and I happen to have these three scores, and I type it in, and there is no grade, which means in the end, this student who got this score, let's say extra credit of 1 point, 2 points, and 5 points extra, and he get an average of 102 or 103, and the student doesn't get a grade at all. So that's not good. Let's test it. What happens if the average grade or score falls below 0? Let's do -10, -1, and 0. Still get an F. Why? Well, because we have this average less than equals to 69, and so it takes anything that is less than 69 and assigns an F. So you have a negative score, it will automatically give you an F. Now, as we have said, that if our average score is only between 0 to 100, and our code, after we run them and tested it, shows that if it is x greater than 100, the average score, you don't get a grade. So there's something wrong there. Now, if it is less than 0, it gives it an F. But as I've stated, if your average score must be between 0 to 100, then we have to fix these two parts here where there's no grade, and when it's less than 0, to let the user know something is happening there, and your average is greater than 100, and also your average is less than 0. We have to let the user know, so the user know how to take care of those outlying or outside scores. So how do we fix the codes? Well, we're going to add a line below our average less than equals to 69. So we say, let's say if the average is greater than 100, then we print out of range average greater than 100. So now if I print this statement out and the user sees this, the user will know that something is wrong with the score, and let's go back and check it, and maybe the teacher entered the wrong score. So now how about we do the one that is going to be less than 0. You shouldn't have a negative score unless the exam that I give or the teacher gives has a negative points assigned to questions that you got it wrong or did not answer. But in our case, we should not have that kind of questions in my class, so therefore you should not get any negative scores. So I put out of range again. All right, so let's run this code and we'll test these two again, because we have tested all these ranges and they work, and now we need to run a few more tests to check these greater than or less than 0. So that's the reason why I asked the class to do test runs and do more than 5 test runs, 5 or more, is to test your codes. So I'm going to do 101, 102, and 103. And there you go. Your average score is 102, out of range, average greater than 100. Now it let the user know, hello, there's something wrong with this. Your score is greater than 100, and it shouldn't be because no extra credit is given. And so there's no way you get more than 100. The perfect score is going to be 100. So that works out great. So let's run negative scores, negative 10, negative 9, 0. Now we have a negative score. It still gives an F, but it tells you it's still out of range. The average is less than 0. Well, the reason why the F is printed because we use average is less than equals to 69. It means that it's going to go all the way back to negative numbers. Now, if I don't want this to show negative numbers or the grade F, I can change the codes here to put 0, less than equals, that way. And this will fix this part here of printing the grade. So let's try it. Negative 10, negative 10, negative 9, 0. This time you don't see the F, right? Right here's the F. Now it just tells you out of range, average is less than 0. So now we can fix the problem and look at the scores. Maybe we enter a negative accidentally. It should be a 10 and a 9. And so that helps the user to fix their problems. In the next lesson, we will look at how we can convert all this mathematical expression that Python allows you to do into proper way of writing codes so that you can apply it to all different languages. Hello everyone. So far we have looked into writing programs for if statements. The first program that we wrote, we used the mathematical operators to write the program, and then I also show you one mistake or a mistake that most students use when they write the first if statements, and also usually during the exams. So now I'm going to move on to use logical operators, and this is the proper way to write your codes instead of using the mathematical operators that we have done before. Here we need to convert these mathematical expression into logical operators so that they will work for all your programming languages when you write if statements in the future. Alright, so let's review logical operators. There are mainly 2 and plus 1, 3. The first one here is AND operator. The AND operator connects two Boolean expressions into one compound expression. Both sub-expressions must be true for the compound expression to be true. So the example that we done some time back, let's go back here. Here. This is a Boolean expression. This is the second Boolean expression. So as long as both are true, then the whole thing is true. So here's the truth table. All right, so a Boolean expression here, a Boolean expression here, because they're called Boolean because it executes to a true or a false. They're also called conditions. So let's go back and look at the next one, the OR operator. The OR operator connects two Boolean expressions into one compound expression. One or both sub-expressions must be true for the compound expression to be true. It is only necessary for one of the sub-expressions to be true, and it does not matter which. So what it means is this: as long as one of your sub-expression is true, then your whole expression is going to be true. So, and then the last one is the NOT operator. It's the opposite. If it's not true, it'll be false. If it's not false, it is true. So let's take a look at how we convert the math operators that we use for the first if statement we wrote into logical operators. And again, I like to stress that starting from now, you cannot use mathematical expressions to write your if statements. you will have to use logical operators to do that. All right, so previously, let's see. This is what we had previously. And now we need to convert this into a logical operator. So to convert this into a logical operator, we're going to use the AND logical operator here because that's the only one that makes sense. So if 90 if average is greater and equals to 90 and the average is less than equals to 90, and then you print A. So let's look at the line graph here. It should be 100 there. Let's change this. Made a mistake. Should be 100. So therefore, it's important to draw your diagram, plan it out before you write your codes, then you make less mistakes. So it says that if average is greater or equals to 90, so average is greater or equals, inclusive because of the equal sign, and then your average must be less than equals to 100, and therefore, if these two conditions are true, then the whole thing is true. It's hard to draw a straight line. There we go. So now let's convert the next one. Next one says if 80 less than equals to average. This is your mathematical expression here again, right? We need to convert this into logical expressions. So this is going to be if average is going to be greater equals to 80 and average is less than equals to 89. If you draw the line graph, that will be 80, 89. So let's check. If average is greater equals to 80, greater equals to 80, and the average is less than equals to 89. So basically it's in this range. All right. Let's see if I can draw this. Okay. So you will finish off with the one for the 70, and then the 68 or 69 is going to be exactly the same. So you will end up with this code right here. So top part doesn't change, the input doesn't change, the average part to calculate the average doesn't change. The only part that we are talking about is the if statements here. So the if statements have now converted into a logical operator. So the original if average, so the original is going to be this. Okay, now we need to convert that into logical operators and do the same for the rest. And even here for the last one where I use less than equals to 60, it should be 69 here. Let's change the code. Okay, and now I have this program with the if statements converted into logical operators. Again, I like to stress you have to use logical operators from now on. You're not allowed to use this kind of expression. This is not acceptable when in my codes for class, for homework, for tests. You have to use the logical operators and not mathematical expression this way. Now let's try and run this code and see what is the result. Start Python. And let's pull the codes back up again here. And I'm going to make it a little bit smaller. All right, so you can see what we're doing here. So the shell is up. Now I need to put new file. This is where I write the code. So again, so program to assign letter grade using logical operators. So the first part here is going to be your input statement. And we're going to type in the 3 input statements there. Again, I'd like to remind you, please try not to copy and paste your codes and then run it from the notes that I give you. The best thing to do is to type it out so that you learn. Now, of course, the part where is repeated, you can just copy and paste. There's no problem. But new stuff, okay? So for example, with the logical statements, it is highly recommended that you type it in. Okay, so this part is basically the same. You can copy and paste. So here should be calculations. All right, I made a shortcut. Instead of calculating the total, I went ahead and do average is equals to test1 plus test2 plus test3 divided by 3. Now, if there are multiple equations to get into a final equation, and your equation is super long, break it down. So what I meant was, let's say your average is 3 steps to get to the average. Break it down into 3 steps. It's better to put average and then 3 steps all in one equation. Because if something goes wrong, we can fix your codes quickly by testing each one of those equations. And we know which one is wrong. We'll fix that one. And then now the whole code is going to work. But if you put all in one line, then I can't tell whether it was the total that was incorrect or was it the total divided by 3 that was incorrect. I hope you understand what I'm trying to say. So next part here is going to do the output. Okay, that will include your if statements. Now this is the part that you should type it in yourself. Average greater equals to 90 and average less than equals to 100. And do not forget the colon, then print A. Okay, so now you will type the rest in. And now we check. So AND operator, AND operator, AND operator, and we also use the AND operator between 0 to 60. 9 over there. And now we are ready to run your codes. So let's give this a name. Let's call this Grace 3. Okay, logical operator. Save this. And to test score 1, we're going to test the first one here between 90 and 100. So we do 95, 96, and 98. That should give you an A. It didn't print the A. Let's see what's the problem. Let's look at the codes. Can you figure out what is the problem? This is the line of code for this. All right. So what is the problem? Well, here I put average greater equals to 100. So this is true. Average greater equals to 90. That's true. But average is not greater equals to 100 because the average here is 96. So I have set the wrong relational operator. Let's fix this. Less than equals. Okay. Let's run this again. I'm just going to put this over here. So we could see it. So let's run 95, 96, and 92. Yep, that shows an A. So we fixed that. Now let's do a second test run. So now we're going to test 80. So we do 80, 85, 89. That's a B, that works. Let's do the next test run. We'll check for the C. So 70, 75, 70, 78. And that works. So we've tested out 1, 2, 3 statements and they all work. Let's test the last one. So we go below 69, so there'll be 50, 40, and 20. That should give an F. That works also. So that's the purpose of doing test run. We want to test our codes and see if it works. So far I have 1, 2, 3, 4, 5 test runs, and the first one failed. So the more test runs, the better. The minimum that you're supposed to do for your labs and your homework is 5. So now I need to test some more because I need to test for the outlying numbers. For example, anything greater than 100, and those are less than 0. So I'm going to test for greater than 100, 101, 110, 120, because there's no extra credit for this class, so there shouldn't be any average that's higher than 100. So it says the average score is 110 and there's no grade assigned. Now, as the user will not know what happened. They'll run the codes, and then later on you see that you're going to run many data, and you will not be able to notice one data that is missing a letter grade. So we need to, again, let the user know that something is wrong here and flag it. Next one here, let's run negative. Negative 10, negative 9, and 0. Again, no letter grade was shown, and as a user, I may not see it, or I just totally missed it. There's no grades assigned. So I need to know, I need to let the user know, hey, no grades have been assigned. So how would you change the codes? What line of code would you add to change the code in this program? What would you do? Well, let's try this. If the average, right, is less than 0, and let's use the OR operator, OR, because OR means as long as one is true, the whole thing is true. So as long as average is less than 0, or the average is greater than 100, as long as one of this Boolean expression here, or well, let's call this, Boolean expression or sub-expression is true, then the whole thing is true. Then go here and print to the user, out of range or not valid grade. Now, it should highlight in green because it is a string. I'm missing the quotes. And now let's run this again. This time I'm going to run with a positive over 100. And there you go. Average score is 110, out of range or not valid grade. So now the user know, hey, this is not a valid grade. Something is wrong. So let's take a look and see why, right? Now let's run negative. There we go again, negative. It says out of range, a not valid grade. So from now on, you will have to use logical operator to write your codes. And you have seen how we use the AND logical operator, where it's inclusive for a range. And the OR operator is going to be this way. So let's take a look at how this OR operator works. Okay, so let's put this statement in here. I'm going to add this to the bottom. All right, so you know how the line graph for AND operator works. Let's do this. For the AND operator here, the line graph will be 90, right? It says average greater or equals to 90, inclusive. Okay, it goes all the way. But it stops here, 100, and average less than equals to 100. Okay, so it's inclusive in this range. Now what if it is this? If average, using the OR operator, if the average is greater 0 or the average is greater than 100. So your line graph will look probably like this. First it says average greater than 0. I mean less than 0, sorry. So this is not inclusive because there's no equal sign. So it goes that way. And the average is greater than 100, goes that way. So as long as this is true, or this is true, as long as this is true, or this is true, then this whole expression is going to be true.